Our last topic for acids bases is a connection between acid bases and their strength. Now, we've already talked about strength of solutions, right? Molarity tells us how strong a solution is based on how much solute has been dissolved in a solvent. I didn't let you copy the slides. Pause real quick. Now, while molarity absolutely applies to acids and bases, there's a secondary way to do comparative strength of acids and bases called the pH scale. So let's talk about the pH scale together. This first part of the lecture is very, very simple. It's a bunch of simple facts, but it's really, really important that you have an understanding. So plug in. Here's what the pH scale is. There it is. So here's the scale. The pH scale goes from 0 to 14. Therefore, in the middle of that scale is 7. A pH of 7 would describe a solution that is neither acidic nor basic. So in the very middle of that scale is the safest place in regards to worrying about what you're going to come in contact with. So 7, neither acidic or basic. Now, the scale itself, though, has two extremes. Both of the far ends, the 0 and the 14, should be considered dangerous. Because the way it works is when you're near the middle of the scale, and you're water basically, the moment you start clicking away from 7 is when things become acidic or basic, but they slowly become more and more powerful, with the outsides being the most powerful. So 0 and 1 are the most powerful acids, while 13 and 14 are the strongest bases. And again, right in the middle is the safest area. Now, I refer to acids and bases. You wrote in the dark that on the pH scale, the moment you dip below 7 is where you're dealing with acids. Above 7 on the pH scale is basic. But the more chemistry way to say that is that when you go below 7 on the pH scale, you are increasing hydrogen ions, or hydronium, because we already learned that that's the primary substance that signifies an acid. Therefore, when you go above 7, you're increasing hydroxide, since OH minus is the primary substance in bases. Also on here, you'll see a splash of examples at different pH levels. For example, we've already talked about the fact that bases, a pH above 7, tend to be things that clean, while acids, a pH below 7, tend to be found in food. There's other things as well that all of these are found in and used for. Like I bet a bunch of y'all aren't at home drinking your urine. But for those of y'all that do, it's got that slight sour taste, am I right? Anyway, yeah, your P has a pH of 6, which means it's just slightly acidic, but still safe to touch because it is not near one of the extremes. Questions so far? That's the easiest part of the day because it gets a bit more complicated when you introduce the idea that there is a secondary scale. Now, before we talk about POH, realize, most importantly, that the H represents acids, right? We know that hydrogens represent acids, and pH really stands for hydrogen power. It's negative log of H, but it stands for the hydrogen power. So this is the acidic scale. It's basically saying when you go this way, it's more acidic, and when you go this way, it's less acidic. But then we have a scale that looks at substances through the lens of bases. The pOH scale says that as you go up on this scale, it becomes more basic. Down, it becomes less basic because OH only cares about basicity. That's not a word. It's a societal thing that pOH is less discussed than pH. For example, if any of y'all have a swimming pool or a neighborhood pool or whatever, one of the things that they're in charge of doing is keeping the pH levels in check. You'll see that the pool guy will come by and he'll take a sample of water and he'll add some indicator and look at the colors that it changes, making sure that the pool water is within a certain pH range, because if it needs to be near 7. If it gets too far away from 7 either direction, you can't swim in the pool. But the fact that we talk about that instance as him checking pH levels it doesn't even make a lot of sense. We could equally say that he's checking pOH levels, because here's what's true. Every substance has a pH and a pOH simultaneously. Both of the scales are always existing at the same time in any sample you look at. We're just obsessed with pH for some reason, where pOH is just as valuable. The thing that's annoying about the pOH scale is that it's a mirror but reversed. Do you see what the numbers are doing? Anything above my ruler is basic. We already said a pH above 7 is basic, but look at the pOH. A pOH below 7 is basic. Everything below the ruler is acidic. So if you look at the pH scale, a pH under 7 is an acid, but a pOH above 7 is an acid. And that can trick you when it comes to like canvas. So tread carefully and intentionally. Now, the last thing I want to point out about the pH scale is that there is a relationship numerically between pH and pOH. Who can see what it is? At every level, what is true about the two numbers? They always add up to 14, and that's valuable. Draw a beaker with me. Let's put a solution in that beaker. And let's assign a trait to it. The solution in this beaker has a pOH of 5.5. Yes, you could have decimals. They don't have to be whole numbers. I want you to silently think about a pOH of 5.5, and let's draw a card. You're not in clusters, so you are row 1, 2, row 3, row 4, and row 5, seated numerically from front to back. Let's go talk to someone. Let's go over to row number 1, and let's talk to person number 2. Hey, 1, 2, are you good at basketball? I know the answer to that. Here's what I meant to ask. Acidic or basic? The guess is basic. Do you agree? Yes, it is a base. All right, because we've already said that a pOH below 7 is basic. But watch this. Thinking about this fact here. All right, you wrote that in the dark. Let's go over to row 5. Hey, row 5. And C1. Hey, 5-1. Any guesses on what you think the pH is? You have access to the calculator. You're welcome to use it. Say again. 8.5. Y'all like that number? Yeah, it's perfect. Because these two numbers together always equal 14. So if you have one, you know the other. And both of them, of course, support the fact that they're basic, because a pOH below 7 is basic, a pH above 7 is basic, and they both simultaneously exist in all solutions. That's half of the day. Who's got questions? Well, I haven't done that yet. Now, speaking of the formulas, though, you wrote these in the dark, and all of them are on your formula chart. So that's good news. Even the pH plus pOH equals 14, you don't have to memorize that fact, and it's super useful. But here's what the other thing is that I need you to be able to do. In your packet, please turn to this page. You might want to pause. If you don't have this packet, then pause and write down the questions, because we're going to be answering all 6 of them, and you won't be able to see them. We got it? Okay, yeah. This is the rest of lecture, is these 6 questions. You do need to work them out with me in your spiral on the packet. I don't care. Just somewhere that you will be able to re-access them when you need to see what you've done. All right. What this skill is the ability to have molarity talk to pH. We said that molarity is strength. We said pH is strength. So how do the two numbers communicate with each other? Well, it's your new formulas. I really want to give a deep intro on using these because it deserves it, but let's start this first question. Look at that first question. It gives you hydrochloric acid, HCl, and it asks for pH. All of the problems that we do for pH calculations having molarity talk to pH values from the scale. All of them are going to give you the identity of a compound and then either pH or pOH. Focus in. Here's the thing. First off, before we do the big thing, these equations deal with logarithms. Luckily for you, we don't go deep into logarithmic theory. So for the most part, logarithms for you are going to just be a button on your calculator. Look at your calculator, look at it. Look at the button below the second key. Do you see the word log? That's logarithm. Anyway, back up here. If you take the negative log, right, not the minus log, the negative's at the very bottom of the calculator. If you take the negative log of a molarity, if that molarity, look what I'm pointing at. Am I pointing at an acidic substance or a basic substance? Acidic. If you take the negative log of an acid, it'll give you pH. If you take, look here, the negative log of a OH minus, acid or base. Base. If you take the negative log of a basic concentration, it'll give you pOH. This is a really big deal because sometimes it'll give you a base and ask for pH. And those things don't talk to each other. What I'm saying is if it gives you a base but wants pH, if you take the negative log of the base, it's only capable of spitting out pOH. And you have to get your brain wrapped around that idea. But here's how it works. Let's go back to our problem. HCl, is that an acid or a base? It's an acid. Hey, look right above my finger. Look there, look there, look there. H, is that an acid or a base? Acid. If those two things match up, then it's an easier problem. All the problems are easy. It's just when they don't match up, there's one really easy, simple step to add. But if they match, then you just take the negative log of the concentration. So let's practice that once. They match. So I'm going to go negative log, in this case, of 5.5 e negative 3, 5.5 e negative 3. And since I'm taking the negative log of an acid, it will spit out a pH. Try it. Remember, hit the negative button at the bottom of the calculator, then the log button, then enter in that molarity. As far as sig figs go, acids and bases, or rather pHs, have their own set of sig fig rules that are not awesomely fun, but we're not going to worry about those. All right, we'll worry about those next year when we hang out. Instead, we're just going to go 2 digits past the decimal. So what I get if I round is 2.26. Did you get a pH of 2.26? If you didn't, call me over. I want to fix your button pushing. That's a minus. That's a minus. You did negative. See the negative? Negative. You hit minus instead of negative. Anybody else need me? So see the times 10. That's represented by a capital E on your calculator. So 5.5 second button. And then negative, not minus. Negative.
Here, they just keep going right now. What?
So negative log, yeah, you're getting negative log 5.5 second button. Yeah.
I did that. It's a negative.
Yeah, but it's not negative one. Negative one.
Oh, negative one. Oh, yeah.
Hey, is this pH acidic or basic? Acidic, because any pH below 7 is acidic. Let's do another one. All right, let's pull out some data from our second problem. It mentions sodium hydroxide, and it wants to know pH. Let's see if it's a one-step or two-step problem. The first one was a one-step problem because they matched. They were either both acids or both bases. Here we go. NaOH, is that acidic or basic? Basic. See the OH, hydroxide? So this is a base. All right, look at this right here. pH, is the H acidic or basic? Acidic. I'm unplugging someone's AirPods, I'm sorry. Move it here, move into another outlet for real, I don't mind. Wait, how is it you? Hello?
Hello, I'm calling for Crystal, please.
No thanks. Do you see how they are mismatched this time? So look, here's the deal, If they're mismatched, there's going to be two steps. Watch me think through this. We are still going to go negative log, but they gave us a base. If you take the negative log of a base, it will spit out POH, and that is not what they want. Watch how we fix it at the end. Let's still go negative log, all right? So let's go negative log right, of given is 9.4 e negative 5 times 10 to the negative 5, which will spit out a POH, as we already said. Get that number. I get 4.03. You all right with 4.03 for POH? But we're not done because of the mismatch at the beginning. I don't want a POH. It is asking for pH, but what's the easy trick to find that number? We know that these two values always add up to 14. So we can easily just do 14 minus 4.03 to get an answer. Turn up a second, left next to it. So, to summarize all the math we're doing, if they match at the beginning, you'll just take negative log and be done. If they mismatch at the beginning, you'll still take negative log and then subtract from 14. Let's see if this makes sense. Do both of these next two, please. Call me over if you're stuck. Let's talk to the audience. Let's go over to row 2. And we will talk to seat 5. Hey, 2-5. I'm wondering, yeah, it's you. Hey, the first one, I just want to know match or mismatch. Mismatch is correct. Starts with H, so it's an acid. OH is a base. So I know right away there are 2 parts to what I need to do. But the first part, of course, is just negative log of the concentration, 2.6 E negative 7. But I know that since I'm taking the negative log of an acid, it's going to spit out a pH of 6.59. That is not the answer, though, because it doesn't want pH. It wants POH. So the difference from 14 will give me 7.41. Yeah? Let's go somewhere else. Let's go over to row 5. Seat 3. Hey, 5-3. On the other one, match or mismatch? Match is correct. Look at the OHs yelling at you. Both of them are bases. And if they match, then it's just a one-step problem for you. Just negative log. So let's go negative log of the given concentration, 7.9 E negative 2. That's the molarity. I'm taking the negative log of a base, which means it will spit out POH. Of 1.10. Hi. Yeah. Here, you reteach the rest of the class. You stay in your seat.
Ready.
I know how to do the base part. What? Shut up! That's a smart. What? So the next one, you just do 10 over 10.
Okay, I'm back. Hey, I'm back. We have one other thing to cover. I need you to be able to go the other direction. All right, which means what if they give you pH and they want to know these molarity numbers that they've been giving us? Still just as easy, all right? It's a different formula that we haven't used yet, but the match mismatch is still a thing. So let's take a look. You want to play millionaire? Say no? Okay. Again, let's extract some data from the new problem. I see HBr, and I see that it gives me a pH. says the pH is 2.11. So there's data from the question. That's aggressive. Okay. Hey, acid or base? Acid, that's good news. Oh, okay, well, it's just news. Here comes the good news. Hey, acid or base? Acid, because it's just the H. So hooray, we haven't done this yet, but we know that matching is a good thing. All right? In order to turn a pH into a molarity, the other direction, all we do is we go, for an acid, it's 10 to the negative pH. For a base, it's 10 to the negative pOH. If they mix match, which is not happening here, we'll fix it. But if I go 10 to a negative pH, which I have a pH this time, then it will give me an acidic molarity. So we want to go 10 to the negative 2.11. Negative, right? It's to the negative pH. Now, if you don't know how to raise to the power on your calculator, you're looking for this button here. There's a couple ways to do it, but this is called a caret. It's a baseless triangle. It's 5 buttons down on the left. Are you finding it? All right, 5 buttons down on the left. It means raise to the power of. So you would put in the number 10, the literal number 10, then raise to the power of negative 2.11. And when you do that, you'll get something. Let's go 2 digits past. Now, we might write this in 2 different ways. I'm going to write it as 7.76 e negative 3. Molar. Your calculator might have said 0.007762 blah blah, which is the same number. I just have trouble writing leading zeros, but it would still be right. But anyways, I get 7.76 e negative 3 molar, which is the same as 0.00776. And that's the molarity. One more. In our last problem, it gives me HClO4, and it gives a pOH of 7.87. Acid or base? Acid, it starts with H. pOH, acid or base? There's the mismatch. Now, you know how when it mismatched going forwards, we would do negative log followed by subtract from 14?
You do it first.
This time, you just do it the other way. Because, look, here's the deal, y'all. If we subtract this from 14, what will it give us in general? It will give us a...
Negative.
No.
Oh, wait.
It'll give us a pOH. All right? If we subtract from 14, I'm sorry, it'll give us a pH. And then if we treat the pH with 10 to the negative, it will talk to an acid, just like we want it to. So what is the difference from 14 here? It's 6.13. Now I have an acidic number to talk to my acidic compound, and we can finish with 10 to the negative 6.13.
Negative 7.